This is just a quick video on how to start implementing EV charging stations in planned communities like HOAs or apartment complexes. So first of all, it's just sort of a big picture. What you will want to add are level 2 charging stations. These have 240 volts. This means this is what people put in their garage to, say, charge a car overnight or, a few hours, in a few hours after they return from work. You don't want to put in fast charging stations like you find out on the highway because those are just prohibitively expensive. Even the level 2 charging can be expensive. So what I want to go through in this video is that you do not need to do this for every unit. As you we'll see that not everyone needs to be charging all of the time. So you just need enough units to be able to cover most situations. Also, government shouldn't be telling HOAs and apartment complexes that already exist that they need to electrify every space because it's really not necessary. You really need to have a plan for the future. Cars are, probably over the next 20 years, cars will be getting electrified, and therefore we need to be ready for that over the next 20 years, or your HOA or apartment complex will be a dinosaur. So EV charging is like rolling a die. So I have two scenarios here that really turn out to be the same mathematically. So the first one is if you roll a die 20 times, what is the chance that fewer than 5 rolls will come up as a 1? Okay, that would be the same question. What is the chance that 20 EVs can be supported by no more than 4 charging stations? If you have 4 charging stations, you don't want 5 people to be trying to charge at the same time. So we're going to pretend that rolling a 1 on a die is like somebody wanting to charge their car. And as long as not too many people want to do it at the same time, things will work. So mathematically, these are the same question. So most of you probably don't want to actually see the math, but this is how you would figure out the probability of rolling fewer than 5 ones out of 20 rolls. So this would be comparable to having 4 charging stations and never needing more than that. Okay, so P0 represents the probability that no one, there are no ones. P1, there's 1 out of 20. 2 would be 2 out of 20, 3 would be 3 out of 20, 4 out of 20, and so on. You wouldn't want to have more than 4 out of 20 at a time in this dice rolling game. But we can extrapolate that out to cars. The only thing that will differ is the probability of rolling a 1 isn't the same as the probability that a car will need to be charging. Okay, so we need to do a little bit of exploration. What is the chance of an EV needing to charge? And then will there be a station available? Right? To figure this out, you need to know the chance that any one car is charging. And then you need to know how many EVs you have. So that's kind of like how many times you're going to roll the die. And the number of charging stations that you have, that limits how many of those EVs can be charging at a time. So let's explore a little bit further. Okay, so in this slide, this goes through sort of the mathematics of figuring out what's the probability that a car will be needing to charge. So the first assumption is that a typical car in your community would need to charge about 4 hours for every 100 miles, and that's about what they would drive locally in a week. If somebody takes a road trip from Maine to Florida, they're not using your charging station to do that. So it's only the local charging that you need to worry about. So for people, they're weekly driving. So 100 miles seemed like a reasonable number for that. And based on some cars in my community, I assume that would take about 4 hours to charge. People won't be able to charge every minute of the day, so I estimated they're about 112 hours per week. That's assuming people can charge all 7 days for 16 hours. People aren't going to want to be unplugging their charger in the middle of the night. So if you're they're going to be billed to sit there overnight, they won't want to do it. So I assume 16 waking hours. And the key is that gives us a probability of 3.57% that any one car is charging at a given time. So that's a lot lower than the probability of rolling a 1. So that would be 1 in 6, which is significantly higher than 3.57%. All right, continuing on. The probability that I used was for one of my friends' Tesla Model 3s. And so that was the 4 hours to go about 100 miles more. But you have to consider other things. The plug-in hybrids, people want to plug them in almost daily. It probably isn't an ideal car for someone who lives in an apartment or an HOA. If you're using shared charging stations, they're great if you have a garage. SUVs, some of them are going to have large electric SUVs coming along, and those will obviously take longer to charge because they have much larger battery packs. But other things may lower that, as maybe people can charge at work instead of charging at the HOA. And where the battery technology is changing every day, cars may be able to go further on the same batteries. Then all kinds of things could happen in the future, like we might have robo taxis or car sharing, where people aren't using cars in your community, they're borrowing cars from outside of the community. Now, here's a sort of a bar graph showing what happens. Okay, so with the probability of charging that I had, if you had 20 cars in your community and you had 4 places to charge, 4 charging stations, they usually come in pairs. So you'll probably want to start with 2 stations or 4 stations. You can see that most of the time, the first bar shows that most of the time, nobody will be charging. And then if you had 4 stations, sometimes you would have 1 person charging at a time, sometimes 2, 3, occasionally 4, but that's a pretty low probability. And beyond 4 is very, very low probability, which is why 99.9% of the time, everyone will be able to find a charging spot. So it doesn't, most of the time, no one will be charging, but this means that hardly anyone would ever be blocked out of charging if you had 4 stations for 20 cars. If you expanded that to 56 cars, you would still be able to get everyone charged 95% of the time. What that means is, if you look at the bar graph, what's shaded in, those would be the probabilities that no one would be charging, 1 person, 2, 3, or 4 people would be charging. That takes up 95% of the probabilities. Every once in a while, 5 people will want to charge, so 1 person would get blocked out. Occasionally, it might even be 6. Beyond that is will almost never happen. So that means 4 stations could still service up to 56 electric vehicles in a community. So continuing on, if you go to 93 cars, in order to have the same 95% chance of finding a charging station, you would want to go up to 6 stations. So now 6 stations would allow 93 cars to charge. So you can see in the bar graph, we're fine all the way up to 6 cars charging. The most likely scenario is that 3 would be charging at a time. But it would be fairly rare that you would have 7 or more cars needing to charge. So 95% of the time, people should be happy and be able to find a place to charge. If you keep going, I'm not going to continue making the bar graphs. You can kind of see how many stations give a 95% chance that you will be able to charge your car. And the key is, as we go further and further down, the ratio is settling in very nicely. So at first, you really need to, as cars add into the community, you will have to add pairs of charging stations. But over time, it becomes much more predictable where, by the time you get to 16 stations, you can service 19 cars per station. You can see down when you only had 4 stations, you could really only count on that servicing 14 electric vehicles. But the ratio is approaching 20 to 1. So if you have a larger HOA and more electric vehicles, a 20-to-1 ratio of your charging stations to potential electric cars is what you would need in the future. Also, it would be silly to build them all at once. They're expensive. You probably want to build it into the fees to build them out slowly. Since you probably have close to 0 electric cars right now, you could slowly work your way from, maybe starting at 4 stations. That would buy you a lot of time. And probably every few years, you could add a pair of charging stations until you're servicing your whole community. In summary, everyone's going to be driving an EV in your community. The hardest part of this is getting through the paperwork and all the red tape for getting your first couple of stations, getting residents in line with it, determining which parking spaces are going to be the ones taken over for charging. So you don't want to do too much too quickly because if people see empty charging stations, they're going to want to park their car there. So it's good to start with a couple and then slowly, as the number of EVs grow, keep growing the number of stations. Eventually, you'll hit that 20-to-1 ratio, and that should be sufficient. So, one charging station per 20 cars means that about 5% of your parking needs to be converted to charging. So that's means 95% of it doesn't need to be changed at all. So come up with a plan that will probably get you there in over a 20-year period. For most HOAs, you can budget this in and make it affordable without having to raise dues. We don't need to make it any major changes to infrastructure in order to make this happen. So I hope that's helpful. Key idea is you don't need to convert your entire community over to electric charging stations. You'll have plenty of time to do it. You just need to start now and build out for the future. I hope that was helpful.